Okay, we're going to go ahead and put some technology to, or some terminology, and having technology problems. We're going to put some terminology to the problem that we did last time. So last time we saw we were looking for the slope of that line that just touched at a point, and that gave us the instantaneous speed. And that type of line is called a tangent line. So a tangent line to a curve at a point is a line that just touches the curve at that particular point and has the same direction as the curve at that point. So lots of words. Tangent lines are not too scary though. So I've got an example, a couple examples graphed below that you can look at, but let me do another example here. Just draw a curve. So let's pick a point, pick any point, and we can talk about a tangent line at that point. So if I pick this point here, the tangent line has the same direction as the curve at that point and is just barely touches at that point. So think about like zooming in at this point and asking yourself, if I draw a line that looked like the curve at this point, what would I get? And in this particular case, it might be something like this. Imagine that is a perfect straight line. So that would be an example of a tangent line. Maybe at this point here, the tangent line might look something like this. So we're thinking this is a line that just kisses the curve at a particular point, has the same slope as the curve at that point. So let's pick another point that maybe has a negative slope. Ooh, it's hard to draw lines. Goodness, very hard. Let me use the ruler here. This one might be about the slope there. And once again, it should touch at that point. There we go. Maybe something like that for that tangent line. Okay. So these are tangent lines. It's okay that the tangent line might touch at another point, but it's not a tangent line to this particular point. It's a tangent line to that point, the point where it just barely touches. Okay, we saw in the previous problem that slopes of tangent lines gave us instantaneous speeds. And so finding the slopes of tangent lines is an important question for us as we move throughout the semester. And that's actually the question that we'll ask ourselves this whole semester. How do we find the slope of tangent lines? Because slopes of tangent lines can tell us things like instantaneous speed, instantaneous velocity, instantaneous rates of other change. Okay, we saw in the last problem in the last video that finding the slope of a tangent line is a problem because for tangent lines, we only have 1 point. We need 2 points in order to find the slope of a line. So we use lines to approximate tangent lines. Those are called secant lines. Secant lines just take 2 points on a curve and join those 2 points with a line. And the benefit of secant lines is that we can actually find the slope of them because they've got 2 points. So we use secant lines to approximate the slope of tangent lines. And let me just draw an example of a secant line. So if I have this curve, pick my favorite 2 points on here. If I join those 2 points, that is a secant line. Pick 2 more points that I like and join those 2 points. That is a secant line. So for a secant line, I just need 2 points on a curve that I join. Okay, we use secant lines to approximate the slopes of tangent lines. Okay, let's do an example to see how this all works, especially with the terminology. So let's estimate the slope of this tangent line to the square root of x at x equals 1. This is the same idea as what we were doing in the first problem, just rephrased. The very first problem, we could have said, find the slope of the tangent line to this function at t equals 2. So just a different phrasing of the same question. So we could also phrase this as find the instantaneous velocity at t equals 1. So let's look at the graph of this and before we get started. Okay, so what I have here in red is square root of x, and I have that tangent line graphed at x equals 1. So this is the tangent line in green there. That's the line that we're trying to approximate the slope of. Remember, we can't actually get the exact value of this slope because we only have 1 point on the curve, and we could probably, or on the line, we could probably guess another point based on how it's graphed on Desmos here, but we might not always be able to find those exact other points. So we're going to use secant lines to approximate the slope of that tangent line. So let's pick another point on our curve, maybe this point way out here, like 6. That's the secant line. That line is not perfectly the tangent line, but its slope will approximate the slope of the tangent line. Notice if I move the second point closer to the point I cared about, that secant line, these are all secant lines, gets closer and closer to that tangent line. It looks more and more like the line we're looking for. So what we're going to do when we approximate slopes of tangent lines is we're going to pick points really close to the point that we care about. In this case, x equals 1. We're going to pick points close to 1, and we're going to find the slope of the secant line between those 2 points. And those secant lines will approximate the slope of our tangent line. Okay, so we'll go back to my notes here in just a second. Okay, so in order to approximate the slope of this tangent line, we're going to use some secant lines. So let's pick x values that are close to 1. And the way that we pick these is usually picking things like 1.1, 1.01, 1.001, and seeing what happens. So the way that I set this up is I set an interval. My interval always is going to include 1 because the 1's the point that we care about. And I'm going to pick a point close to 1, like 1.1. And then in my second column, I'm going to write the slope of the secant line between those 2 points. Okay, and I'm going to write the details out for this first piece and then kind of leave out the details for the second one. So we have that curve, square root of x. We have the 0.1, and then I'm going to like over exaggerate this and write 1.1 way out here just so that we can look at the picture better. And so I'm looking for the slope of the line between those 2 points. So the slope of this line. That's the thing that I'm going to get an exact value for. So to find the slope of the line, we need the change in y values over the change in x values. The y values are based on the function I'm working with. So the y value here will be f of 1, and this will be f of 1.1. In this case, our function is just square root of x. So my y value here is square root of 1.1, and here it's square root of 1, which is just 1. So my y values, my slope of that line will be the change in y. So f of 1.1 minus f of 1 over the change in x. The x values are 1.1 and 1. And so remembering here, our function is square root of x. So I'll have square root of 1.1 minus square root of 1 over 1.1 minus 1, and type that into a calculator. Keep a lot of decimal places, like 5 or 6 decimal places for these types of problems. So you get 0.488088. Okay. So that secant line is an approximation of the slope of the tangent line. We want to take points that are closer and closer to x equals 1 so we can see what these slopes are doing. So let's pick another point that's closer to 1, like 1.01, and then we'll pick 1.001. When I find the slope of those secant lines, so now find the slope of the secant line just like you did in the previous problem. So we'll do f of 1.001 minus f of 1. Oops, sorry, that 1.01. Over 1.01 minus 1. Okay, plug those into your calculator, remembering our function is square root of x, and we get 0.49875. And see if you can calculate the last one on your own. Actually do the calculation. I get 0.499875. Okay, so these are a bunch of secant line slopes. We have to ask ourselves, how do we use that to get the slope of the tangent line? Well, we say, what are these numbers getting closer to? Well, what do you think? They look like they're getting closer to 1/2 to me. So to me, I would guess that the slope of our tangent line is 1/2. 1/2 is a positive number, a fairly small number, fairly small slope. That seems to agree with the tangent line that we saw. It had a positive slope, but didn't look like a super steep slope. So all seems reasonable. Today, we had a lot more videos than we'll usually have, and this is maybe a little more complicated than what we'll do over the next couple classes. So if this feels a little hard, don't worry, we'll do a lot more practice with this in class. That's why we watched the videos. So just hold on, don't get too freaked out yet. Ask me questions in class and we'll go from there.